This concept from physics education research will change how you think about equations forever. Hi, I'm Abby, and I'm a third-year astrophysics student. This year, at a summer internship, I found out about a new concept, well, not new, but new to me concept, that I found super interesting and definitely changed how I think about equations. This concept is called symbolic forms. Now, I know it sounds boring or stuffy or confusing or, I don't know, pick your adjective, but I promise, once we break it down into pieces and look through some examples, it's not that bad. It's actually really helpful. Symbolic forms are tiny pieces of knowledge or thought that help us connect the structure of an equation to the meaning of that equation. They were first introduced by Professor Bruce Sharon of Northwestern University as a way to think about how students interpret equations. A symbolic form has two parts, the physical structure and the meaning behind that structure. Here's an example. This is the parts of a whole form. It has the structure of a bunch of things being added together. Thing plus thing plus thing. And it has the meaning of a whole composed of two or more parts. Anything can go in those little boxes. Whenever you see something added to something else, you can think of it as parts of a whole. But wait, sometimes one structure can have multiple meanings. Actually, often one structure can have multiple meanings. Here's a different example. This is base plus change. When it's seen in context, say with the velocity equation, it looks pretty much the same as parts of a whole. Both involve two items being added together, but their meanings are different. This equation doesn't just represent two things being added. This equation better is represented by base plus change, a base velocity plus a change, the acceleration times time. Now, let's do a little practice. Do you think this equation is better described by parts of a whole or base plus change? Trick question! Actually, this equation can be viewed in both ways. First, it can be interpreted as base plus change. The standard physics interpretation of this equation is distance equals starting velocity plus change in velocity. But this equation can also be viewed as parts of a whole. Take a look at this graph. This is a graph of velocity over time. There's a constant rate of change, so the slope doesn't change, so the graph is a straight line. This is because acceleration is constant. Because this is a graph of velocity, the area under the graph is the distance traveled. This has to do with integrals and derivatives. We can split this graph into two portions. The bottom portion represents v naught t, since the height is v naught and the width is t. The top portion represents 1/2 at squared. And that may seem weird, but here's why. The area of a triangle is 1/2 base times height, as you probably know. The height of this triangle is change in velocity, and the width of the triangle is change in time. So we can call these delta v and delta t, respectively. We can multiply this quantity that we have by delta t over delta t, which is basically just 1 because the denominator is the same as the numerator. Then we can rearrange to get 1/2 delta t squared times delta v over delta t, which we can further rearrange to get 1/2 a delta t squared. Thus, we can add the two parts together to get v naught t plus 1/2 at squared, which is the same equation that we had earlier. And now, instead of looking at it as a base plus a change, we're looking at it as two things added together, two parts of the whole area. Symbolic forms are useful in cases like these because they let you think about how you're thinking about the equation. They let you ask questions like, how am I interpreting this? Is this the best interpretation? What would be a more useful way to think about this? Learning to recognize the patterns in equations is a key skill for upper-level physics, and it's best learned simply through practice. One way you can practice is by taking a look at symbolic forms. With this in mind, here are my 3 top tips for practicing with symbolic forms. First, flashcards. In the description, you can find a link to Sharon's original list of symbolic forms. Take a look through these and find the ones that you think would be the most helpful for interpreting the equations that you usually use in your physics class. Make some flashcards and practice matching the meaning to the structure. 2. Practice identifying symbolic forms in the equations that you have in class or on your homework. And 3. Make a list of the symbolic forms that you find most helpful as you practice and as you try identifying different ones. Make sure you keep track of this list and save it for later, so that whenever you're confused in the future, you can take a look at your list and use the forms that you remember to piece together the equation. If you're ever confused about what an equation is telling you, just refer back to your list. The more you practice recognizing patterns in equations, the better you'll get at interpreting new ones you encounter. Now, you can interpret equations like a pro. Thank you for watching, everybody! Don't forget to take a look in the description for the link to Sharon's original list of symbolic forms. That way, you can brush up and make sure that you're interpreting your equations properly. Bye!